Imagine standing in the middle of the West Texas desert. To your left, stretching as far as the human eye can see, is a shimmering ocean of glass and silicon. But there is a problem. A massive, fundamental flaw that physics dictates and that engineers lose sleep over. The sun is setting. As that golden orb dips below the horizon, this multi-billion-dollar infrastructure turns into nothing more than expensive glass decoration. We have built our dreams on a power source that decides to clock out every single evening. But now, let's transport you to a small, unassuming town in Wyoming. Here, on the site of an old, dying coal plant, something radically different is taking shape. Rising from the scrubland isn't an oil rig. It is a wall. A massive, industrial honeycomb structure stretching wider than a football field. This isn't the sound of energy being created. It is the sound of the atmosphere being scrubbed. This is Stratos. Behind those massive grates are fans, colossal, high-torque fans that are literally sucking the sky into a chemical trap. To undo 200 years of the Industrial Revolution, we have been told that the solution to climate change is planting trees. Biology is too slow. So, American engineers have decided to build a synthetic forest. Trees made of steel, piping, and advanced sorbents. Today, we are looking at the blueprint for terraforming Earth. Terrifying scale of the invisible garbage hovering above our heads. Since the first steam engine roared to life, 2.5 trillion tons of carbon creates a thermal blanket around our planet, like trying to stop a bathtub from overflowing by turning off the tap. But the bathtub is already overflowing. Legacy carbon. DAC was considered science fiction, thermodynamically impossible. Build an industry the size of the existing oil and gas sector in reverse. The first hurdle is a problem of dilution. Nitrogen 78%, oxygen 21%, CO2 only 0.04%. Capturing from a coal plant is easy. Open air is a nightmare. Like trying to find a specific grain of red sand on a mile-long beach. You have to sift through an unimaginable volume of material. This is why the fans are necessary. Must be so massive.
As this comparison shows,
the challenge is the kinetic energy penalty.
Dwarfed by the sheer scale of the Stratos
Every
complex.
cubic meter of air has mass.
Stay tight on those fins. We're losing
Aviation-grade aerodynamics to minimize drag. Operate at low speeds to reduce noise and energy. Sucking in dust, pollen, moisture,
It's coming loose on
insects.
sector 4. I see it. Hold the brace.
Intake systems must filter out
Make
physical
sure the alignment
debris.
is correct on that main pipe.
Copy
If
that.
the
We
air
are
moves
moving
too
it into
fast,
position now.
it doesn't spend enough time
All
to
right,
react.
Bring it up. Bring it up. Watch
If
your
it moves
depth
too
over
slow,
here.
you aren't
Keep that
capturing
vibrator
enough.
steady.
The holy grail of DAC aerodynamics. Epicenter of this revolution. Permian Basin in Texas. Stratos. Designed to capture 500,000 tons. This is a leap of 2 orders of magnitude. Resembles a
They call it
massive
the
industrial
Stratos
radiator,
facility, a monument to human
composed of
ambition
hundreds of
etched
identical
into the
contactors.
wasteland.
If one fan breaks, service that one module. Concrete foundations. Withstand high winds. Prevent air recirculation. Inside the contactor units, magic happens.
Get a close-up on that filter.
Chemically sticky to CO2.
The viscosity is holding steady at 200 centipoise.
There are 2 paths to capture: liquid solvents and solid sorbents. Liquid solvents. Giant honeycomb structure with liquid solution dripping. The solution turns into a carbonate salt. A pellet reactor forms little pellets of calcium carbonate. Solid sorbents. Highly advanced sponge filter. Metal organic frameworks, MOFs. The challenge is the regeneration phase. How to get the CO2 out. For liquid solvents, you must heat the pellets to roughly 900 degrees Celsius. This energy-intense heating releases the pure CO2 gas. Solid sorbents are the new breakthrough.
The diagram illustrates
They require
how the
less
dense
heat,
layer prevents migration from
often
the
just
porous
100
zone.
degrees. This dramatically reduces the energy penalty of the entire system.
Get the camera closer. Look at
Where
the
do we
white
put it?
veins.
We're getting a reading now.
You can't
confirming
store it in
high-density
tanks.
carbon.
Geologic sequestration. The CO2 is condensed into a supercritical fluid, pumped thousands of feet underground. The storage is in porous rock, like a hard sponge. An impermeable layer called cap rock acts as a lid. In some locations, the CO2 is injected into basaltic rock, where it chemically reacts and turns into stone. It becomes physically impossible for it to leak.
Here we see the stark reality of the split world. where natural decay meets industrial neglect.
Check the power fluctuations on grid 7.
It's stabilizing, but the solar input is dropping faster than projected.
Power levels are spiking. I'm initiating the bypass sequence now.
The enrichment levels are spiking.
Reroute the coolant immediately. We can't afford a shutdown.
This technology creates an ethical conflict.
We're seeing a spike in CRBN futures.
Enhanced
volume
oil
on the last
recovery, EOR.
Get me 1,000 at 50 right now.
We're seeing a
Sometimes,
spike in Sector 4.
The
Reroute
CO2
auxiliary
is
power
pumped
now.
into old oil fields
Acknowledged.
to push
Running
out the remaining
diagnostics.
crude oil. This provides a vital revenue stream for the DAC industry, but it offers a lifeline to keep drilling. This is the central debate. Is DAC a solution to climate change, or a subsidy for the fossil fuel industry? The forest versus the fan. Flux density. Amount captured per square meter. Trees stop growing in winter. Can die from disease. When a forest burns down, carbon released back. A geological injection well is a permanent vault. DAC is 2,000 times more land efficient. It doesn't compete with food production. A mature forest is carbon neutral. The machine never stops. Runs 24/7. Nature is stochastic. We need the machines. This process is exorbitantly expensive. Currently $600 to $1,000 per ton. Wright's Law, the learning curve. Seen this with solar panels. Every time production doubles, the price drops by a predictable amount. The process consumes a staggering amount of electricity. DAC facilities must be paired with dedicated renewable energy sources, or dedicated nuclear reactors. The business model is to trade tons of removed carbon. The service is planetary survival.
Look at the temperature on that gauge. It's nearly maxed out.
We need to back up soon.
Maintain the focus on the shale. The heat signature is spiking near the vent.
I'm trying. The haze is making it difficult.
Get the flare, tilt up. It's blistering out here. We're getting heavy chromatic aberration on the edges. Stay close, visibility is dropping fast. I'm trying to get a focus lock, it's too thick.
This machine is kidney dialysis. Natural organs are failing. We are becoming the architects of the atmosphere, building a thermostat for the planet. This is a terrifying responsibility. Monuments to human ingenuity.
We need stabilization on Sector Gamma immediately.
Physics is sound.
Rerouting power now.
The variable
Status in
is our
T-minus
will.
30 seconds.
The road ahead is long and monumentally expensive. It will require a coordinated effort from scientists, engineers, investors, and governments, on a scale rarely seen in human history. The technology to forge a cleaner, more sustainable world exists. It is humming away right now, in the high desert of Texas, turning air into stone. This is more than just a new industrial process. It is a profound statement about humanity's capacity to correct its own mistakes. The carbon era is ending, not because we ran out of fuel, but because we invented a superior solution. The age of the synthetic forest
All right, moving now.
is upon us. Click that subscribe
Unit
button.
3B, we have stable pressure readings across the main tank. Continue monitoring the heat exchange.
The power levels are fluctuating again.
I see it. Initiating sequence stabilization protocol.
The sensor readings on Sector 4 are spiking. I repeat, spiking. We need confirmation on the ground now.
Yeah, come on, go, go, go! Look at that view. It's incredible. Keep going, don't stop yet. Watch the edge. That's enough, bring it up slow.
That thick green substance is the chemical agent. The heat haze makes it difficult to get a clear reading on the levels.
The infrared is spiking on grid 4.
Reroute auxiliary power now. We're losing stabilization.
The air here is barely breathable.
The data streams are showing an anomaly in the primary reactor.
Cross-reference with the seismic monitors. I need confirmation on that spike.